Hi guys, today I'm going to discuss about introduction to Verilog HDL. By the way, myself Dr. T.M. Sathish Kumar. That is a verification logic hardware description language. That is VHDL. That is Verilog HDL. The Verilog standardized as IEEE 1364 is a hardware description language used to model electronic systems. It is most commonly used in the design and verification of digital circuits at the register transfer level of abstraction. It is a language used for describing a digital system like a network switch or a microprocessor, memory, or flip flops. It means by using HDL, we can describe any digital hardware at any level which are described in HDL are independent of technology and very easy for designing and debugging and are normally more useful than schematics, particularly for larger circuits. The Verilog module syntax here, the Verilog modules describe three steps. The first one is a module, then second one is port declaration, that is port, then third is procedural statement or hardware declaration. These all are the three steps for Verilog HDL syntax. Okay, here there are four types of Verilog HDL modeling available. The first one is structural or gate level modeling, and second one is behavioral modeling, and third one is data flow modeling, and last one is switch level modeling. Here the structural modeling is the lowest level of abstraction in Verilog. It is also called gate level modeling because we only describe hardware in logic gates and their interconnections. This is the one example of structural modeling or gate level. Here the full adder circuit shown in figure. In this full adder circuit designed with the help of two half adders and one OR gate. In this circuit having two XOR gate and two AND gate and one OR gate. Okay. In this circuits having three inputs and two outputs. The inputs are A, B and C in. The outputs are sum and carry. Here the module, that is S and C out, that is the output, and A, B, C in, that is input. We are going to describe the input A and B and then output sum and carry. The wire is nothing but the signal between output and input, that is wire 1 connected between the XOR gate and XOR 2. Okay, therefore we are giving by wire. Now the coding of Verilog code for structural modeling in the full adder circuit. Here module, the name is full adder. The module content is sum, C out, A, B and C in. These are the input and outputs. And then wire is nothing but the in and out. For example, the XOR gate 1 output goes to the input of XOR gate 2. Therefore we are going to declare the wire. Okay, that is wire 1, wire 2, wire 3 denoted by W1, W2, W3. Here the XOR gate 1, the output of XOR gate 1 is W1, the input is A and B. Then XOR gate 2, the output is sum, the input is wire 1 comma C in. And then AND gate 1, the output is W2, the input is A comma B. And then AND gate 2, the output is W3, the input is B comma C. Then finally OR gate, the output is C out, the wire is, that is W2 and W3, all are the inputs. Then finally end module. This is the structural modeling for full adder circuit, the corresponding diagram. The next modeling is behavioral modeling. The behavioral models contain procedural statements which control the simulation and manipulate variables of the data types. These statements are contained within the procedures. Each of the procedures has an activity flow associated with it. The behavioral model depends on the truth table, the flow of truth table. Here the full adder consists of, that is outputs sum and carry, the inputs A, B and C. Here the always at, the output changes between the inputs, therefore A or B or C declared in always statement. Then finally case, here the case is declared by the inputs A, B and C in. The flow 3 of binary formation 3 bit, then behind sum equal to 0 and Cout equal to 0. Then second flow, that is 0 0 1, that is sum equal to 1 and carry equal to 0. Then finally the 3-bit binary form 111, that is sum equal to 1, Cout equal to 1. Then end case, end begin, end module. These are the behavioral modeling for full order circuit, the flow of truth table. Next model is data flow modeling. Here the data flow modeling makes use of the functions that define the working of the circuits instead of its gate structure. The data flow modeling uses several operators that act on operands to produce the desired results. Verilog provides about 30 operators types. Data flow modeling describes hardware in terms of the flow of data from input to output. It is mainly used to describe combinational circuit. The primary mechanism used is a continuous assignment. Here the data flow modeling, the operators and the description shown in figure, that is AND operator and NAND, OR, NOR, XOR, XNOR. There are 30 operators available for using data flow modeling. Here the data flow modeling mainly depend on the Boolean expression or Boolean functions. Here the sum A XOR B XOR C in and Cout equal to AB plus BC plus C in. Here the module we are declare the inputs and outputs. Some assign sum equal to A symbol, that is XOR symbol, B XOR and C in. The Cout equal to A and B or B and C or C and A. Then end module. This is the program for data flow modeling full adder. Then last one is switch level modeling. In this switch level modeling purely depend on the CMOS, that is NMOS and PMOS switches. The switch level modeling is used to model digital circuits at the MOS level transistors. It is recently developed design and analysis methodology for MOS VLSI circuits. And at the switch level, important features of MOS circuits can be directly modeled using a moderate number of discrete parameters, including switch states, resistance, capacitance, and bidirectional signals. Here, the symbol of PMOS and NMOS shown in figure. The CMOS consists of PMOS and NMOS. Here, the PMOS connected with the VDD and the NMOS connected to VSS, that is ground. The one example of switch level modeling in this circuits describe the two-input NOR gate. Two-input NOR gate. Here the W is wire between the A and B transistor. The switch level modeling circuits and coding examples shown in figure. The CMOS two-input NOR gate describing here. The inputs A and B, the output is Y, and W is wire, that is connection between the two transistors. Okay. Then module switch NOR gate, that is Y is the output, AB is the input. The supply 1 indicated by VDD, that is power supply PWR. PWR is the Verilog keyword, and supply 0 indicated by, that is ground, VSS. Okay. Then wire W, the MOS 1, the output is W, the input is A and PWR power. Then MOS 2, PMOS 2, that is our output is Y, input is B comma W. Then NMOS, here the NMOS output is Y and input is A and ground. Then second NMOS, that is Y output, B is input and ground is another input. End module. This is the switch level modeling for CMOS two-input NOR gate. Thank you. So these all are introduction to Verilog HDL coding and modeling styles. Thank you. Thank you so much.